Greetings and welcome to the Introduction to Astronomy. In this episode of New Discoveries in Astronomy, we will talk about how stellar activity may alter radio signals before they ever leave their home star systems. So, let's get started. Could a signal be hiding in plain sight? For decades, astronomers searching for technological radio signals have often focused on extremely narrow radio transmissions. The reason is simple. Nature rarely produces radio signals concentrated into such a small range of frequencies. A narrow signal stands out against the cosmic background and is easier to recognize. But a new study suggests that even a perfectly narrow signal may not remain narrow for very long. Researchers are not suggesting that this effect has already been observed in extraterrestrial transmissions. Rather, they are exploring the possibility that turbulent plasma surrounding a star could alter a radio signal before it ever leaves its home system. The environment around a star may reshape a radio transmission before it ever escapes into interstellar space. Stars are not quiet objects. They produce stellar winds, magnetic activity, and enormous eruptions known as coronal mass ejections. These processes fill the space around a star with turbulent plasma. When radio waves travel through that plasma, their properties can change. Instead of remaining concentrated at a single frequency, the signal can become spread across a wider range of frequencies. Scientists call this process signal broadening. The information carried by the signal may still be present, but the signal becomes weaker and more difficult to detect. The challenge is not that the signal disappears. The challenge is that it no longer looks the way astronomers expect it to look. How can scientists study this effect? The researchers did not examine alien signals. Instead, they used radio transmissions from spacecraft operating within our own solar system. As those signals pass through the sun's plasma environment, astronomers can directly measure how turbulence affects radio waves. Those measurements provide a natural laboratory for studying signal distortion. Researchers then use those observations to build models of stellar environments around other stars. By doing so, they could estimate how much signal broadening might occur before a transmission escapes its home system. By studying how radio signals behave in our own solar system, scientists can estimate how similar processes may affect signals around distant stars. Scientists measure a nearby phenomenon and then apply what they learn to places they cannot directly observe. The study suggests that this effect may be especially important around M-dwarf stars. These stars are smaller than our Sun, but are often far more active. They produce intense magnetic activity, powerful stellar winds, and frequent eruptions. M-dwarfs are also extremely common. In fact, they make up roughly 3/4 of all stars in the Milky Way. If radio transmissions around these stars become broadened before escaping into space, then some signals may fall below the detection threshold used in traditional searches. This study does not suggest that extraterrestrial signals have already been detected, nor does it provide evidence that technological civilizations exist elsewhere in the galaxy. Instead, it highlights a possible limitation in how searches are conducted. Many SETI programs are optimized to detect extremely narrow signals. If stellar environments naturally broaden those signals, future searches may need to consider a wider range of signal shapes. In other words, astronomers may need to search for what actually arrives at Earth rather than what was originally transmitted. This discovery reminds us that understanding a signal requires more than detecting it. Scientists must also understand the environment through which that signal travels. A radio transmission may carry information about its source, but it also carries the imprint of the space it has crossed. And by learning how stars reshape those signals, astronomers can improve their ability to interpret the messages hidden within the cosmic noise. So that concludes our discussion on are stellar winds hiding radio signals. We'll be back again next week for another episode of New Discoveries in Astronomy. So until then, have a great day, everyone, and I will see you in class.